The analog gods, the titanic schism between Maranello and Stuttgart, Ferrari F40 versus Porsche 959. The late 1980 seconds represent the most violent and intellectually profound schism in the history of automotive engineering. It was a moment of transition where the mechanical era met the digital dawn. This was the era of the Group B fallout, a period where racing technology, developed for the most dangerous rally stages on Earth, was suddenly orphaned by the FIA and forced to find a home on the asphalt of the public highway. This transition birthed two machines that would define the hypercar for the next half-century: the Porsche 950 and the Ferrari F40. This was not just a battle for top speed, it was a total war between the cybernetic future and the analog absolute. 1. The architecture of the lab, the Porsche 950 and the quantum leap. The story of the Porsche 959 begins with a technical paradox orchestrated by Helmut Bott. While the automotive world was perfecting the internal combustion engine, Bott was reimagining the car as a decentralized computer network. To understand the 959, one must look past its silhouette, which still echoed the 911, and examine its molecular structure. The thermal revolution. Hybrid cooling. At the heart of the 959 sat the Type 959/50 engine, a 2.85-litre flat six that remains a masterpiece of thermal management. To any know-it-all who claims Porsche was just air-cooled, the 959 provides a definitive rebuttal. Bott knew that to extract 450 horsepower from such a small displacement while maintaining reliability, air cooling alone would fail. The 959 utilized a hybrid cooling architecture. The cylinder barrels remained air-cooled, but the four-valve cylinder heads where the most intense thermal stress occurs were water-cooled. This allowed for much tighter tolerances in the valve seats and prevented the microscopic warping that usually plagues high-boost engines. The heads were essentially welded to the barrels through a process of extreme precision, eliminating the need for a traditional head gasket, which is often the first point of failure under high pressure. Sequential turbocharging, the relay race of air. The 959 was the first production car to master sequential twin turbocharging. Unlike parallel systems where two identical turbos work together, the 959 used two KKK units managed by a complex set of bypass valves. At low RPM, below 4,000, all exhaust gases were funneled into a single, smaller turbocharger to provide immediate torque and eliminate turbo lag. As the engine reached 3,900 revolutions per minute, a microprocessor-controlled valve began to pre-spin the second, larger turbocharger. When it reached 4,300 revolutions per minute, the bypass opened fully, and both turbos worked in concert. This created a thrust that was not a kick, but a relentless jet-like surge that pushed the car to its 300 revolutions per minute's redline without the violent lag and blast delivery of its Italian rival. The PSK System. Predicting the physics of the road, the true technical fortress of the 959 was the Porsche Steuerkupplung, PSK. This was the world's first variable torque split system. Using a series of 6 wet plate clutches located at the front differential, a computer monitored wheel speed, steering angle, throttle position, and even turbo boost pressure. The PSK didn't just react to slip, it predicted it. In normal dry conditions, it sent 80% of the torque to the rear wheels, but it could split the power 50/50 instantly if the sensors detected a loss of traction. The driver could select 4 modes: traction, 50/50 lock, snow, wet, and normal. A detail for the most meticulous fans. The 959's gearbox was a 6-speed unit, but the first gear was labeled G for Geland, terrain. With a ratio of 3:50:1, it was an ultra-low gear designed for the Paris-Dakar stages, allowing the car to crawl over obstacles. This is perhaps the only 200-mile supercar in history designed with the ability to navigate a desert dune. Magnesium and air. The hollow, spoke rims. Even the wheels were a technological masterpiece. The 959 featured hollow spoke magnesium rims manufactured through a vacuum casting process to avoid microscopic air bubbles that could weaken the structure. These spokes weren't just hollow for weight, they were part of the tire's air chamber. This allowed Porsche to install the first tire pressure monitoring system, TPMS. A central sensor measured the total air volume. If a spoke cracked or a tire leaked, the driver was alerted immediately. This was critical because the 959 used run-flat tires developed by Bridgestone, the RE70, which was so stiff that a driver might not even notice a puncture at 100 miles per hour. 2. The purity of the scaffolding. The Ferrari F40 and the brutalist ethos. While Stuttgart was digitizing performance, Maranello was preparing a final, visceral tribute to Enzo Ferrari's 40th year of leadership. The F40 was developed in just 13 months, a timeline that would be impossible today. Led by Nicola Materazzi, the F40 was not a car, it was a hollow-point bullet. The hybrid chassis, Kevlar, carbon, and glue. The know-it-all often simplify the F40 by calling it a carbon fiber car. The reality is much more complex and technically superior for its time. The F40 utilized a hybrid space frame. The core was a traditional lattice of high-tensile steel tubes, but this was reinforced by large panels of Kevlar and carbon fiber bonded to the frame with structural epoxy resins. This wasn't just for weight saving, it provided a torsional rigidity of 28,000 Newton-meter degrees, staggering for the 80 seconds. A key point of precision. The F40's body panels were made of a sandwich of Nomex and carbon fiber. To save every gram, Ferrari used a paint layer so thin, only 2 liters of Rosso Corsa for the whole car, that the weave of the carbon fiber is visible through the paint under direct light. This is a mark of authenticity, not a defect in quality. The early models featured sliding windows made of Lexan, a polycarbonate that saved several kilograms over glass but was prone to scratching. The Tipo F120 AV8, the parallel explosion. Under the massive rear hatch, which features exactly 5 louvers on each side for cooling, sat the 2.9-litre V8. Unlike the Porsche Sequential system, the F40 used parallel twin turbos from IHI. Both turbos were identical and worked in unison. This created the most famous torque wall in automotive history. Below 4,000 revolutions per minute, the car felt like a standard 3-litre V8. But as the turbos reached their 1.1 bars of relative boost, often incorrectly cited as 1.6, which is the absolute pressure, including atmospheric pressure, the engine erupted. The management of this explosion was handled by the Weber Marelli IAW electronic fuel injection and ignition system, which utilized 2 injectors per cylinder. To prevent the turbos from cooking the engine after a high-speed run, the IHI units were water-cooled, a vital detail that allowed the F40 to be driven hard and then restarted without damaging the turbo bearings. Aerodynamics. The science of the NACA duct Leonardo Fioravanti at Pininfarina designed the F40 with a focus on laminar flow. The car is covered in NACA ducts, submerged intakes that scoop air without creating the drag of a protruding scoop. The huge duct on the hood cools the radiator, while the side ducts feed the intercoolers. The F40 had a drag coefficient, CX, of 0.34, which is higher than the 959 0.31, but the F40 produced significantly more downforce. Its massive rear wing was integrated into the bodywork, creating a high-pressure zone over the rear 335/35 ZR17 Pirelli P0 tires, keeping them pinned to the road at the 201 miles per hour, 324 kilometers per hour limit. 3. The philosophical war, digitization versus physicality. The clash between the 950 and the F40 is best understood through the interface between the machine and the driver. The 959 was insulated. It featured power steering, power brakes with ABS, and a computer that thought for you. It was a car that allowed a person of average skill to drive at 90% of its limit. It was the first user-friendly supercar. The F40 was exposed. It had no power steering, no power brakes, and no electronic safety nets. To stop an F40 from 200 miles per hour, the driver had to exert over 80 kilograms of force on the unassisted brake pedal. It was a car that demanded a professional level of skill just to operate it at 50% of its potential. The legacy for the future, the Porsche 959, predicted the Bugatti Veyron, the Nissan GT-R, and the modern Porsche 918 Spider. It proved that complexity could be harnessed to make a car faster and safer. It won the war of the future. The Ferrari F40, however, won the war of the soul. It remains the ultimate benchmark for tactile engagement. As we move into an era of electric hypercars like the Rimac Nevera or the Lotus Evija, the F40 stands as the analog god, a reminder of a time when the only limit on performance was the quality of the metallurgy and the courage of the man holding the steering wheel. 4. The verdict of the track. Historical testing and the reality of telemetry. To understand how these two machines shocked the world, one must look at the data collected by the era's premier technical publications, such as Quattro Ruote in Italy and Automotor und Sport in Germany. These were not mere road tests, they were sessions of ballistic telemetry. In 1988, independent testing revealed a truth that marketing departments had tried to soften. The Porsche 959, thanks to its PSK system and all-wheel drive, made anyone look like a professional racing driver. In the 0-100 km/h sprint, the 959 stopped the clock at 3.7 seconds, a figure that remained unbeaten for nearly a decade. The Ferrari F40, despite its significant weight advantage, struggled to put its 577 Nm of torque to the ground through the rear wheels alone, often recording times around 4.1 seconds due to excessive wheel spin and the violent onset of boost. However, once past the 200 km/h mark, the laws of physics switched sides. The F40, devoid of catalytic converters in early versions, and featuring a much more open internal fluid dynamics setup, began to claw back the distance. While the 959 hit a wall of mechanical drag created by its complex AWD hardware, the F40 continued to pull with taurine ferocity. In in-gear acceleration tests, the Porsche showcased the superiority of its Bosch Motronic electronic management, which kept the engine in an optimal efficiency window. The Ferrari, by contrast, demanded the driver shift with surgical precision. A single mistimed gear change would drop the engine into a turbo hole, costing precious seconds. 5. The economics of the myth, selling at a loss vices. Pure profit. A socio-technical detail often ignored by Saputelli is the financial balance sheet behind these projects. The Porsche 959 was one of the most successful financial failures in history. Porsche sold each unit for approximately 420 million lire, but the actual production cost due to the complexity of the PSK system and the aramid reinforced body was estimated at over 1 billion lire per car. Every 959 delivered was a debt that Porsche willingly accepted to gain a technological advantage that it would amortize across the 911 range for the next 30 years. The Ferrari F40 was the exact opposite. By utilizing the existing mechanical base of the 288 GTO and a far simpler construction approach, no complex hydraulics, no predictive electronics, Ferrari generated immense profits. Originally intended for a run of only 400 units, the demand was so overwhelming that Maranello eventually produced 1,315. This created a paradox in the collector market. The 959 is technically rarer, fewer than 350 units. Yet the F40 has become the ultimate cultural icon, causing its market value to frequently surpass that of its German rival.
6. The mechanic's nightmare, degradation and maintenance. This is where the owner of a hypercar faces the reality of extreme engineering. Maintaining a Porsche 959 is a feat of hydraulic engineering. The ride height adjustment system uses a specific mineral fluid circulating through a labyrinth of high-pressure lines. If a seal fails, the entire system can collapse, requiring hundreds of man-hours just to access the components. Furthermore, the magnesium wheels are subject to galvanic corrosion. If they are not X-rayed regularly, microscopic cracks can lead to catastrophic wheel failure under high aerodynamic loads. The Ferrari F40, while simpler in concept, has its own technical demons. The most infamous is the fuel bladder system. To save weight and comply with FIA-derived regulations, the F40 does not have rigid aluminum tanks, but flexible rubber cells filled with anti-surge foam. These bladders have a certified shelf life of 10 years. Beyond that, the rubber degrades, risking debris in the Weber-Marelli injection system, or, worse, fuel leaks onto a mid-mounted engine that operates at extreme temperatures. Replacing them requires the near-total disassembly of the car's rear section. Furthermore, the Marelli IAW injection system in the F40 lacks the self-diagnostic capabilities of modern ECUs. If one of the two phase sensors falls out of sync, a single bank of the V8 can run lean, leading to a melted piston within seconds under full boost. It is a car that offers zero forgiveness for technical neglect. Integration. The molecular secrets of the F40 and the 959. 7. The lubrication doctrine. Dry sump vs. thermal stability. A crucial technical distinction lies in how these engines survived the G-forces they generated. The Ferrari F40 utilized a sophisticated dry sump lubrication system with 2 scavenge pumps and 1 pressure pump. This allowed the engine to be mounted significantly lower in the chassis, dropping the center of gravity, but it also meant the oil tank was a separate unit located behind the right rear wheel arch. A detail for the enthusiasts: checking the oil on an F40 must be done with the engine running and warm. Otherwise, you get a false reading that could lead to overfilling, a mistake that can blow the seals of the IHI turbos. The Porsche 959, despite its 911 heritage, featured an even more complex oil-to-water heat exchanger. Because the heads were water-cooled, Porsche engineers had to ensure that the temperature delta between the air-cooled cylinders and the water-cooled heads remained within a specific range to prevent thermal shock. This was managed by a thermostat that controlled not just the water flow, but also the oil cooling priority, ensuring the engine reached operating temperature evenly, a masterpiece of mechanical synchronization. 8. The suspension war. Double wishbones versus electronic damping. The F40's suspension was a direct evolution of Formula One, thinking of the early 82nds. Double wishbones at all four corners with Coney adjustable dampers. However, the know-it-all often missed the fact that the F40 had an optional, adjustable suspension system that used hydraulic actuators to raise the nose. If this system fails, the car becomes undrivable on anything but a mere smooth track. And the cost of the actuators is legendary in the Ferrari service world. The 959, meanwhile, featured 8 shock absorbers, 2 per wheel. This was not just for redundancy. One damper handled the ride height, while the other handled the damping characteristics. The computer could change the damping stiffness in milliseconds, a precursor to the modern MagneRide systems. This allowed the 959 to be as comfortable as a Mercedes-Benz S-Class on the highway, and as stiff as a Group C car on the track, a level of bandwidth that the F40 simply did not possess. 9. The turbocharging fluid dynamics. The wastegate and the Boeing sound. The sound of these two cars is defined by their wastegate management. The F40 features a central exhaust pipe that is dedicated solely to the external wastegate. When the car hits full boost, the scream isn't just engine noise. It's the raw atmospheric dump of excess exhaust gas. The 959, being sequential, had a much more hushing sound, similar to a jet engine. This was due to the complex plumbing required to pre-spool the second turbo. The air didn't just move. It was managed by a series of check valves and bypasses that functioned like a pneumatic orchestra, ensuring that the transition between the small and large turbo was undetectable to the driver's seat of the pants feel. Interesting technical details for the enthusiasts. 1. The magnesium myth. The 959's wheels were so brittle, due to the magnesium content, that they required specialized machines for tire changes to avoid cracking the rims. 2. The F40's fuel tanks. The F40 had 2 fuel tanks, one on each side. In Europe, these were rubber bladders, FT3, that required replacement every 10 years for safety, a massive maintenance cost often ignored by casual fans. 3. The G gear. The 959's first gear, G, had a ratio so short it was essentially for low-speed maneuvering and steep inclines, meaning the 959 effectively functioned as a 5-speed car during high-speed highway driving. 4. The CX detail. The 959 achieved its 0.31 CX, partly because it had no external door handles, they were hidden in the door jamb, and a completely smooth and closed underbelly. 5. Brembo brake hardness. The F40's 330mm cast iron discs lack any vacuum servo assistance. If you brake lightly, the car doesn't stop. If you brake too hard, you lock the wheels instantly. It requires a calibrated leg. 6. The sport weight. The 959 Sport version weighed exactly 1,350 kilograms by removing the air conditioning, central locking, and the tiny rear seats found in the Comfort model. 7. Fuel as coolant. Under full load, the F40 can consume 1 liter of fuel every 1.5 kilometers. The engine management actually uses an over-rich fuel mixture to act as an internal coolant for the sodium-cooled exhaust valves. 8.959 active aero. Beyond ride height, the front flaps closed electrically to direct air under the flat floor, creating a primitive but effective Venturi effect to increase high-speed stability. 9. The magnesium gearbox. The 959's gearbox casing was cast in magnesium, not aluminum, to save weight and dissipate heat faster. However, this makes it extremely sensitive to torque settings on the bolts. One over-tightened bolt can crack the entire casing. 10. F40's clutch weight. The F40 uses a twin-plate clutch. Because it has to handle the violent torque hit of the parallel turbos, the pedal weight is approximately 20 kilograms. Driving an F40 in traffic is a literal leg workout. 11. Aerodynamic stalling. The F40's rear wing was designed so that at very high speeds, above 300 kilometers per hour, the airflow would slightly stall to reduce drag and allow the car to reach its 324 kilometers per hour top speed, sacrificing some downforce for raw velocity.